Hello. So we are starting our new notebook today. So the last notebook was out ionic bonding, and now today we're going to start learning about covalent compounds. So what I had you do was to go ahead in the response sheet and talk about some observations that you made between these two. So some things that I would pick up is that, this side has these charges, positive and negative charges. This side, I don't see any of those. This side has the brackets, and this side doesn't have any. Some things I notice over here is that we have these dots that aren't bonded with something else. We see prefixes in the names, which we don't see over here, and no brackets or anything like that. So those are just some of the things that I was hoping you might observe. And then as far as the poem, we have sodium atom walks onto the scene, valence electron feeling keen. So we know sodium has one valence electron. Positive that he will ionically bond. So positive, because sodium's going to want to give its one electron away, which will make it sodium with a +1 charge. And it is a metal, so that means it's going to want to bond with a non-metal. He spots chlorine on the other side, sporting her valence shell with pride. So we know chlorine has 1, 2, 3, 4, 5, 6, 7. Chlorine is a non-metal. Sodium's attraction, he just cannot hide. So the duo walks out as sodium chloride, which is sodium chloride, because the sodium would give its one valence electron to the chlorine. So then we'd have sodium chloride. So why would sodium want to bond with halogen? It has one valence electron, and the halogens all have 7, so it would very easily be able to give its one electron. Why is sodium positive? We talked about it's going to be giving its one electron away, so it becomes positive. And why are sodium and chlorine's valence so ideal to join together? Sodium has one to give away, chlorine needs one, so they match up perfectly. So that was kind of some of the things I was hoping for you to think about. So this is ionic, what we did in the last notebook, just to kind of sum that up before we move on to covalent. All right, so the covalent pages look similar to how we worked through our ionic ones. So they're the same type of concept. We're still thinking about the octet rule, but now we're thinking about covalent. So the first thing that's kind of key to notice and how we can tell that something is covalent. Hydrogen is, of course, H, chlorine is Cl. The type of element is what's going to be a big indicator. Hydrogen is a nonmetal, and chlorine is also a nonmetal. So that's a big indicator that we have a covalent. Remember, ionic was a metal and a nonmetal. Now we have two nonmetals. Okay, so if we look up our electron configuration, hydrogen is just 1. So it has one valence electron, one electron at all. Chlorine is 2-8-7, so it has 7 valence electrons. Remember, ionization energy is the energy to remove an electron. So hydrogen's is 1,312, which is really high because that one electron is very close to the nucleus. And the nucleus is positive, it's holding that negative electron. Hydrogen has 1, so it can either gain 1 more to make its full shell of 2, because that's the one exception to the octet rule, because it only has 1 shell, and the first shell can only fit 2. So it can gain, it can lose, and it's very close to the nucleus. So that's why that's a high energy to remove. Chlorine's is 1251, and again, we know that's high because it doesn't want to remove an electron, it wants to gain one. Electronegativity is our attraction for electrons. And chlorine's is 3.2, which is high. Remember, 4.0 for fluorine is the highest. We would expect it to be high because it very much wants to attract an electron. And then hydrogen is 2.2, kind of in the middle, because it could either go either way. It could gain, it could lose. So now our electron dot is a little bit different for these. We are not going to be giving an electron away. We're not going to be having those positive and negative charges. So this type of idea is not going to be happening. Covalent electrons are going to be shared. So they're going to share electrons in order for both to be happy. Nobody's going to be giving its electron to anything else. Okay, so that's one of the big differences. So I usually just draw a rough draft of what the two look like over here on the side. So hydrogen has 1, chlorine has 7. And then I kind of go down to then making the diagram. So again, they're going to share. So hydrogen is not giving its electron to the chlorine. Hydrogen is not a metal, so it's not going to do that. So what happens is we have hydrogen and we have chlorine, 1, 2, 3, 4, 5, 6, 7. And then we draw a circle around them to show that they're sharing those 2 electrons. Okay, so this is important. We're going to circle the shared pair. Okay. So hydrogen has 2 electrons, 1 of its own, 1 that it's sharing, so it ends up with 2 total. So it has 1 of its own and 1 that it's sharing, which gives it its 2, which is a full quote-unquote octet for him. Chlorine has 7 of its own and 1 that it's sharing, so that gives it its total of 8, which makes it happy. Okay. So our formula, we have 1 H and we have 1 Cl, so HCl. And we only have 1 of each. We use prefixes when we're talking about covalent. Remember, we don't say mono on the first one though, just like we don't say 1X in math. So we would say hydrogen monochloride. Okay. It's also, HCl is also hydrochloric acid, more commonly known. A lot of times covalent will have maybe like common names that we're a little bit more comfortable with. But the idea that now when we're talking about covalent, we use prefixes. So big differences. Ionic was metal and a nonmetal. Now we have 2 nonmetals. The electrons are going to be shared. So there's no arrows, there's no positive ion and negative ion. Nobody's positive or negative, they're sharing. And then we have prefixes when we name them. Okay? All right, so let's look at another one. So the next one is carbon and hydrogen. I want to switch colors. All right, so carbon we know is C and hydrogen is H. Carbon is a nonmetal, hydrogen is a nonmetal. They're both on the right side of the table. So they are both nonmetals. So as soon as we see that they're both nonmetals, that tells us that we're going to have a covalent compound and we are going to be sharing electrons. Okay, we're not transferring. All right, so electron configuration, if I look up carbon, it's 2-4. So it has 4 valence electrons. And hydrogen, we know has 1, just 1 valence electron. We already looked up the ionization energy was 1,312 and the electronegativity was 2.2. We already talked about those on the previous one. Carbon's ionization energy, or its ability to remove an electron, is 1,086. It's pretty high still because it has 4. So, you know, does it want to get 4, lose 4? It's sort of kind of in the middle. Electronegativity is 2.6. It's relatively attractive, so it's just kind of hanging out in the middle, kind of neutral. All right, so valence electrons, I'm going to do my little rough draft over here. So carbon has 4 and hydrogen has 1. Okay, so we know we want carbon to end up with 8 and hydrogen to have 2, so we're going to kind of do a rough draft. So when we see carbon, carbon is typically going to be the center of a molecule. So we're going to have a carbon with its 4 valence electrons. So if I were to put a hydrogen, sorry, I'm going to change the hydrogen to an X, sorry. If I put a hydrogen here, and a hydrogen here, and a hydrogen here, and a hydrogen here. Carbon now has 4 of its own, and 4 that it's sharing. So the carbon has 8, it's happy. Each hydrogen has 1 of its own and 1 that it's sharing. So each one has 2, which is full for a hydrogen. So we have carbon in the center and we have these 4 hydrogens. We'll do in the next unit what kind of shape it actually makes. It won't actually make this little cross shape. They repel each other, these little ends, so they actually will try to push out and make a 3-dimensional shape, but our electron dots are always just 2D. So our formula, we have carbon, and then we have 4 hydrogens, so CH4. And then our name, we have 1 carbon, and then we have 4 hydrogens, and remember we use prefixes now, and the prefix for 4 is tetra, like a tetrahedral, so it's carbon tetrahydride. Okay. All right, so what I'd like you to do is I would like you to go ahead and try page 5 for me. So it's similar to this. It has carbon. So you're going to have these 4. And then instead of hydrogen, it has chlorine. So you're going to go ahead and see if you can kind of think about what that might look like, or how it might be shaped, what its name might be. Okay, so just try to do your best on page 5 for me, please. Thanks.